Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 8 from the June 2021 International A-Level Pure Mathematics P4 paper. This question here is about differential equations. Now, in this question, we are told that when y is 1, x is 0. And we're given this differential equation, which has got dy dx in it. This is a first order differential equation, which is as far as we go in AS or A-level maths. And we have to solve this differential equation, which normally means you have to write it in terms of, instead of dy dx, y equals. In this particular case, they want us to, in the end, write it as y squared equals some function of x. So now, what we need to do is, we need to get rid of the dy dx. How do we do that? Well, it's pretty simple. You just take the integral of both sides with respect to x. So I'm going to say the integral of dy dx with respect to x is equal to the integral of whatever's on the other side, also with respect to x. So you have 6x y to the power of a third divided by e to the power of 2x. And that's also integrated with respect to x. Okay, now, what happens next here is basically this. You can think of these cancelling out. So you're left with the integral of this 1 dy basically equals, and what we can do here, we can separate the variables. I'll do this in one step. So basically this dy cancels out, and on this side where you've got the dy, all the y terms should end up. So here you have y to the power of a third, which is on the side where it says dx. We want this to end up on the side where it says dy. So we can divide both sides by y to the power of a third. Now, if you divide, 1 by y to the power of a third, you get 1 over y to the power of a third. Now, in order for me to integrate something like this, I would like to express it with the variable on the numerator. So this is the same as y to the power of minus 1/3. So I'm going to write, instead of y to the power of 1/3 on this side, 1 over y to the power of a third on this side, which is the same as y to the power of negative a third. And then this is with respect to y. On this side, I've got the integral of, now I've got 6x. What I can do here is I can write the 6 actually outside the integral, because it's like a factor of this. You can write the numerical factors outside. Okay, so 6 outside. I'm just trying to make my life easier for when I get to actually integrate. And I've got x, the y to the power of a third already divided it out, and e to the power of 2x in the denominator. Again, 1 over e to the power of 2x is the same as e to the power of negative 2x. Okay, just by the laws of indices. So I can write this as x times e to the power of negative 2x. That just makes it easy for me to integrate. So now I have separated the variables, means I brought the y terms on the side which says dy, and I have the x terms on the side that says dx. I've also made it compatible for me to integrate. I've brought the variable terms on the numerator. Now I can integrate. But before I start integrating, I'm going to do something that will make it very easy for us to find the particular value of this differential equation. I don't like to have, if I've got the situation where I don't need to write the plus c and then find what c is afterwards, I try to take advantage of this. So because they gave us particular values, they said when y equals 1, x equals 0. Like I said, when y equals 1, x equals 0. Let's put that on the other side, sorry. When y equals 1, x equals 0. And I also know that I want to find y in terms of x. So I'll put y here, x there, 1 here, 0 there. That's going to help us now when I integrate and I want to find the value of the constant of integration. This will automatically give me it without any bother. It makes life way easier. So now I can start integrating. The side here which says dy can integrate very easily. You have to basically add 1 to the power and then divide by the new power. So this becomes y. Now minus the third plus 1 is minus the third plus 3 over 3, which gives you plus 2/3, positive 2/3. And you've got to divide that by the new power. So dividing by 2/3 is the same as multiplying by 3/2. So this is 3/2, y to the power of 2/3. And the limits here are y and 1. So that side is integrated. Now we got this side. I've got my 6. Now, what I have here is I have a product of two separate terms which are unrelated to each other. This is not like the reverse of the chain rule. The x here is not the differential of what's in the power. So what I have to do here is I have to use what's called the integration by parts. Okay. Now, when you're doing integration by parts, you have to choose one of your products as u and the other one as dv dx. And for u, you have to differentiate it to give you du dx, and for dv dx, you have to integrate it to give you v. The one that you choose as u is critical. It's the one that's going to be something that breaks down when you differentiate it to something simpler. So if you got x and e to the power of minus 2x, well, e to the power of minus 2x, if I choose that as u, when I differentiate it, I'm going to get minus 2 e to the power of 2x, which actually looks more complicated. However, if I choose x as u, when I differentiate it, I get 1, which of course has become way simpler. And that will help me to solve this problem. So you always choose the one that breaks down, if possible, when you differentiate it as your u, and the other one as your dv dx. Now, e to the power of minus 2x, when I integrate this, well, it's e to the power of something. When you differentiate or integrate e to the power of something, it just doesn't change. It stays exactly as it is. However, if there's a function inside the function like we have here, then we have to also divide by, when you're integrating, the differential of what's inside the function, which is negative 2. So this is how this integrates. Okay. Now, the formula for integration by parts is in the formula book, but if you set out your question like this with u and du dx on the left on top of each other and dv dx and v on the right on top of each other, then it's really easy without even looking at the formula book. It's basically u times v, so you just go across, multiply these together. So u times v, that's going to give me minus x e to the power of negative 2x over 2, okay, minus the integral of, then these two multipliers go across. So it's going to be 1 times minus e to the power of minus 2x over 2. Okay, so that's what that's going to give us. And the limits here are x and 0. Okay, that's dx, sorry. To integrate that with respect to x. Okay, so u times v, which is x, or negative, because you've got a minus there, minus x e to the power of minus 2x over 2. And then this times this, which is basically 1 times e to the power of minus 2x over 2, and it's negative. So you've got a negative here. Okay, so let's just tidy this up a bit. Okay, what I'll do is I'll do this at this stage here, this negative here, and this will become positive. All right, and now I'm almost ready to, in fact, I'll just leave it as it was so I can write the next step clearly. Okay, so with this here, what I can do is I can start putting the values in. Okay, I need to put this value in instead of y, and then this value instead of y, and subtract them. So I can do that from now. What I can do also is I can take out this 3 over 2, which I'll do now. Take it out, and then I can say this is y to the power of 2/3 minus 1 to the power of 2/3 equals, and here I've got 6. Okay, I have 6, and then I've got here minus x e to the power of minus 2x over 2, and that minus becomes plus. I can take out also a half from there, and I've got e to the power of minus 2x with respect to x, and I have my limits of x and 0. I'm just trying to make it easy to integrate, so I've taken out the minus a half, that becomes plus a half outside, and now I can integrate that part quite easily. So this gives you 3 over 2 y to the power of 2/3 minus 1. 1 to the power of anything is 1. 1 to the power of anything is going to be 1. Okay, 1 to the power of this. What this means here, this means the cube root of 1 squared. So the cube root of 1 is 1, 1 squared is 1. Okay, so it's going to give you 1 anyway. And here you've got 6, and you've got your minus x e to the power of minus 2x over 2, and here you're going to have plus, and you're going to have a half. Now I can integrate this. Okay, when I integrate this, it's going to give me e to the power of minus 2x divided by minus 2 again, right? Okay, that you just keep it the same, then you divide by the differential of what's inside the function, and that is the limits x and 0. So let me just tidy that side up a bit. This is 3 over 2, and this is y to the power of 2/3 minus 1 equals, and I'm going to take out the half, so it'll be 6 over 2, and this will be minus x e to the power of minus 2x, and this is going to be minus, because you've got a minus and a plus here, and this is e to the power of, well, there's another 2 here, e to the power of minus 2x, and you have x and 0. Okay, so I've now just simplified this fraction. I've taken out a half from both of these, and that gives me 6 over 2 outside, which is going to give me 3. And then I've got this, these two as they are, with that 2 still there. Now I can substitute the value of x and 0 into this side. Okay, so I have 3 over 2. I have y to the power of 2/3 minus 1 equals, this is going to give me 3. I'll also take out a minus, because I've got a minus and a minus in both these terms. And then I can put in x. So it'll be x times e to the power of minus 2x plus, because I've taken the minus out, e to the power of minus 2x over 2. Okay, minus, then I'm going to put 0 in here. So 0 times this is 0. Okay, you'll have, basically this is going to be x e to the power of 0. Okay, so it's 0 times e to the power of 0, which is 0. Plus, remember I've taken the minus out, that's why this became a plus. This is e to the power of minus 2 times 0, which is 0 over 2. Okay, so that's got that part sorted out. Okay, so these became positive here because I've taken a minus out at this stage, right? So I kind of skipped a step. All right, so now this is 3 over 2 times y to the power of 2/3 minus 1 equals minus 3, and this is going to be x e to the power of minus 2x plus e to the power of minus 2x over 2, and this is going to give you minus, this is 0, and this is a half. E to the power of 0 is 1, it's 1 over 2. Okay, that's as far as I've got here. Now I've run out of space, so I'm going to go to the next page. Okay, so I'll just copy this to the next page, and let's see if I can take it easily. So copy and paste. Okay, right, so that's as far as I got. There's something missing at the end. Did I not put the bracket there? Yeah, I missed out the bracket. So there's a bracket at the end, and now we got to, in the end, have it as y squared equals 2. So now first thing I can do is I can divide everything by 3. Then this 3 cancels with this 3. Okay, so I have a half, and I'll just expand this bracket. There'll be a half. All right, I can also multiply by 2 actually. So I'll divide by 3 and also multiply by 2 at the same time, just to get rid of the fraction 3 over 2 at the front. That will give me y to the power of 2/3 minus 1. Okay, so I divided by 3 and I multiplied by 2, so I'm going to multiply by 2, so it'll be minus 2 times, and you have x e to the power of minus 2x plus e to the power of minus 2x over 2 minus a half. So I've got to multiply everything by minus 2. So in that side there, so you got y to the power of 2/3 minus 1 equals minus 2x e to the power of negative 2x, and you're going to have minus 2 e to the power of minus 2x over 2, which gives you basically 1, okay, because 2 times the 2 cancels with that. So it's minus e to the power of minus 2x, and minus 2 times minus a half is plus 1. So now I can add 1 to both sides. So I'll have y to the power of 2/3 is equal to negative 2x e to the power of negative 2x minus e to the power of negative 2x plus 1, which is 2. All right, so now we have to, in the question, they told us to express it in terms of y squared equals some function of x. So I have to write it as y squared. So I have to get rid of this power of 1/3. So I have to take the cube of both sides. I have to cube both sides to get rid of this 1/3. So I've got to cube this side and I've got to cube that side. So this will give me y squared equals minus 2x e to the power of minus 2x minus e to the power of minus 2x plus 2 to the power of 3. And there is the answer to question part A of question 8 from this exam. So we have to express it as y squared equals some function of x, and that's exactly what we've done. And using the method of the limits that I showed you, where you put the limits in at the point where you start integrating, that really helps you to avoid this plus c business and gives you the answer and the constant straight away. It makes your life way, way easier. Okay, so that's the answer to part A. Now for part B. Part B says, hence, meaning using what we just found, which is this, find the equation of the horizontal asymptote to the curve with the equation y squared equals gx. Horizontal asymptote is like a line which is horizontal that the curve cannot touch. Now, if you look at the form of this equation, you have like e to the power of negative something, e to the power of negative 2x. So that type of curve, if you just look at e to the power of minus 2x, that has an asymptote when y equals 0, and it looks like this. It's e to the power of minus in the power, so it's like reflected in the y-axis, compared to e to the power of x. E to the power of x would look like this. E to the power of minus 2x will look something of that form, okay? But it will have an asymptote, okay, the y-axis. As x gets really, really large, y approaches 0, okay? It approaches 0. It gets closer and closer to the x-axis, basically. All right, that's the horizontal asymptote if it's y to the power of minus 2x. Right, so this is, of course, not anything like that, but it's kind of got this e to the power of minus 2x in it. So I'm guessing it will be something similar to this in terms of, you know, where it's going to get close to a particular value. Okay, there's some other transformations that take place. You've got this plus 2 here. So I'm guessing it's going to have something to do with when x approaches infinity, that it goes to some sort of a asymptote. So what I'm going to do is, okay, I'm going to choose x as a really large number. So I'll say let x approach infinity, okay, and see what happens to y squared. Okay, so one of the ways you can do this is just choose a very large number in your calculator. For example, let me choose a number. Let's just say a million. Okay, so that's 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6. All right, so I'm going to store that number to make it easy as A. All right, so 1 million is stored as A in my calculator. Okay, so when I choose that button, like alpha and then that button, it's going to show up as 1 million basically. So I'm going to put minus. So what I'm going to do now is I'm going to put minus 2 times A. Okay, that's minus 2 times A. Then I have multiplied by e to the power of, so that's e to the power of. I'll have e to the power of minus 2a, minus 2 times a. So remember, a is, I've saved a as 1 million, okay, as a large number. Okay, then I'm going to put minus e to the power of, and I'm going to put again minus 2a, minus 2a, and then I'm going to put plus 2. Whoops. I'm going to plus 2. And what I'm going to do is, I forgot to put the brackets here, I'm going to cube this now. So I'm going to put this to the power of 3, and I should put a bracket at the front of the thing as well. all of that is raised to the power of 3. Exactly what this is. Minus 2 times, I've replaced the x with 1 million. So the x here, the a here is in my calculator 1 million. So minus 2 times a million, e to the power of 2 times a million minus e to the power of minus 2 times a million plus 2 cubed. That's what I've got here written here. When I press equals, it gives me the value 8. So we say y squared is equal to 8. Therefore, y is equal to the square root of 8. The square root of 8. Okay, now, yeah, the square root of 8. Okay, the square root of 8, which is equal to 2 root 2. This is root 4 times root 2, which is 2 root 2. Okay, now, they told us in the beginning of the question something. They said y is greater than or equal to 0. Okay, so that's why this could be plus or minus the square root of 8, plus or minus the square root of 2, but as y is greater than or equal to 0, then we say y is equal to just 2 root 2. Okay, y is equal to 2 root 2. This is the asymptote, because this is the number it approaches as x becomes really, really large, right? So that's something which, you know, you would get the marks for that if you just did that in your calculator. You work out, I worked out that as x gets really large, it's going to approach some sort of asymptote, because e to the power of minus 2x approaches some sort of asymptote as x gets really large. So I assume that, and we see that that's what's happened. Now, how do you understand this algebraically? This is enough for you to get the mark, what I've done there. You'll get the mark for that. But I want you to understand algebraically what's going on. So what I'm going to do is I'm going to say, okay, y squared equals, and I'll rewrite this as minus 2x divided by e to the power of 2x minus 1 over e to the power of 2x. Rewriting this in like index form with the power in the denominator if it's negative. Plus 2 cubed. All right? Now, as x approaches a very large number, okay, then what happens to y squared? Well, this is minus 2 times a very large number. Let's call it infinity. Divided by e to the power of 2 times infinity. Okay. Minus 1 over e to the power of 2 times infinity. Plus 2 cubed. Now, if you have something, you know, this is a very large number. And this is a very large number. Okay. But way bigger than that number. When you raise something to a power of something, it gets really big. All right. So if I say, for example, if I say, if I have the number like 100 over e to the power of 100, well, this is way bigger than that. So when you're talking about infinity, okay, this is like almost saying, you know, that this denominator is really huge compared to the numerator, because you're raising this to the power of infinity. So basically, this is going to become 0, because you have something over a huge number gives you 0. If you like 1 over infinity gives you 0. Okay, and the same thing here. This is, you know, 1 over a very huge number, which is also going to give you 0. As this number gets really big, this will tend towards 0, and this will tend towards 0, and you're left with the plus 2 in here, cubed. So we can say y squared is equal to 2 cubed. Okay, so that's y squared equals 8. Therefore, y is equal to plus or minus the square root of 8, as we found before, and then we get the answers as we mentioned. Y equals, we only take the positive one, y equals 2 root 2. That is the horizontal asymptote. So that's like algebraically coming to the answer, and this is by thinking a little bit and bringing, choosing a value x that's really large, okay, to substitute it in, and it will give you the value for the asymptote. Okay, so there's the answer to 8A and part B. I hope that was clear. And thank you for watching. Other questions from this paper can be found in the playlist that will appear somewhere over here. Other questions from this topic of differential equations can be found in the playlist that should appear. The link in this area over here. You can subscribe to my channel by clicking on the link in the middle, and you can see links to other papers and other, you know, like courses like the IGCSE course, and you can see those in the description under the video. Thank you for watching, and see you soon.